to the previous activity where I challenged you to get this rqt-graph. So in order to get this graph, you will need to start a node here, another node here, which, for example, here you can start the Python node you've created, here the C++ node, and then you will need to start some Turtlesim node with remapping. So let's start. We will launch rqt-graph, and for now this rqt-graph is empty. We will start Ros2 run my Python package with the Python node, and the Python node is named PyTest, so we will rename it to custom py, like that. Ros2 remap node custom py. Okay, we have a node, and now we can refresh, and great, we have the first node here. Now let's start another node. This is a really long name for CPP node, but it works. Yeah, why not? Ros2 run my CPP package, CPP node, Ros2. This is a really long name for a CPP node, but it works. And we get this node here. So note that this is just the name of the node, okay? The challenge was to get this graph, but you can also start this node using the Python node, or any node, in fact. It doesn't really matter, because here the challenge is just to get the same graph. But of course, as you can guess, even if this works, it would be much better when you develop to give meaningful name to your nodes. So, for example, if you start a camera driver, then don't call it temperature sensor. Try to always make sense with what you write and what you start. So we have two nodes here, and we will now start the Turtlesim node. Here it's Turtlesim node with name Donatello. Let's start it here. Ros2 run Turtlesim node, and Ros2 remap node Donatello. Okay, we have a new window here. We can see this node here, and now we need a turtle node to communicate with Donatello node. And as you can see, this is the default node name. So I will just start it here. Ros2 run Turtlesim and turtle tiliop. Okay, and actually we will not remap this node. Okay, and if I refresh here, we have if you just go to nodes only, okay, we have the exact same graph. And I encourage you to redo this activity and work with the previous section on node and all the tools to be confident using that, because everything is so for now. We will use it in the next few sections where we will see how to make the nodes communicate between each other. What is a Ros2 topic? Before going to the definition of a topic, I will give you an analogy with a real-life example, so it will be much easier for you to understand. I will make an analogy with a radio transmitter and receiver. As this is a simplified analogy, not everything I will say about radio will be correct, but the point here is to make you understand Ros2 topics. So let's suppose we have one radio transmitter here. This radio transmitter will send some data on a given frequency, and for people to easily remember, this is represented by a number, for example here, 98.7. We can think of 98.7 also as a name, so you know that if you want to receive music from the radio station, you need to connect your device to 98.7. You can see the green box here, 98.7, has a Ros2 topic, and the radio transmitter is a publisher to this topic. So for this case, the data stream is sent over the 98.7 topic. Now, maybe you want to listen to the radio station from your phone. What you will do then is to ask your phone to listen to 98.7. In this case, the phone is a subscriber to the topic. To play the music on your phone from the radio transmitter, you also need to send and receive the same kind of message. Here, if the radio transmitter is sending FM signal over the topic, and if on your phone you are trying to decode AM signal, then it will not work. That's why you need to make sure that both the publisher and subscriber are sending messages with the same data structure. So here you can see the radio transmitter as a publisher, which will publish on the 98.7 topic with an FM signal. The phone will subscribe to the 98.7 topic and will also decode FM signal. Now, maybe you also want to listen to the radio station from another device or from your car. Then, as you know, you just need to listen to 98.7. And also, both your device and your car should decode FM signal. You have now an example with a topic and 3 subscribers. So we can have many subscribers on a topic, but on the other side, we can also have many publishers on a topic. Imagine another radio transmitter, which is also publishing an FM signal to 98.7. It can be the same radio station, it can also be another one. Sometimes, when you are driving, you arrive in a zone where 2 radio stations are publishing on the same frequency. In this case, you have 2 publishers on the 98.7 topic. All these subscribers will receive the messages from both publishers. So here you can see all blue boxes are nodes. You have the radio transmitter node 1, the radio transmitter node 2, and then you have a node for the smartphone, the radio player, and the car. Some nodes contain a publisher to the 98.7 topic, some nodes contain a subscriber. As you can notice, all publishers and subscribers are sending and receiving the same kind of data. And as you can guess, a subscriber is not aware of the other subscribers and is not aware of who is publishing the data. It only knows it is receiving data from the 98.7 topic. On the publisher side, the publisher is not aware of the other publishers on the topic and is not aware of who is receiving the data. It only publishes data on the topic, and that's it. So Each node which is publishing or subscribing to the topic is totally independent. Any combination is possible. For example, you could have 3 subscribers and no publisher. In this case, well, it's working, but the subscribers will just receive nothing, but it's working. If you have 2 publishers on the topic and no subscriber, the data is just sent and no one receives it, but it's still working. Another combination, you have only one radio transmitter which is publishing and only the radio player is subscribing. Well, I guess you see the point. So for now, we saw that you can publish data on a topic and subscribe to it to receive the data. A Ros2 node is not limited to that. In fact, a node can publish on many different topics. Let's say that the radio transmitter node 2 is publishing FM signal on the 98.7 topic and AM signal on the 101.3 topic. The driver of the car just chose to listen to the 101.3 frequency, so the car is now subscribing to the 101.3 topic and decoding AM signal, and thus it will receive data from the radio number 2. A node can contain multiple publishers, but also subscribers. Now, imagine that the car, while listening to the radio, is publishing its coordinates to a car location topic. The car node has now 1 subscriber to the 98.7 topic and 1 publisher to the car location topic. The computer node is subscribing to the car location topic, and for the communication to be successful, both nodes are sending and receiving the same kind of message. Well, that's it for the analogy. Now, you should have a better comprehension of what is a topic and when it is useful. So, to recap, according to the Ros2 documentation, a topic is a named bus over which nodes exchange messages. Note that for the real-world analogy, we used numbers with dots as topic names. That was just to provide you with an easy example, but this is not valid. A topic name must start with a letter, and then can have letters, numbers, underscores, tildes, and slashes. When to use a topic is often when you need to send a data stream. The data stream is unidirectional. Some nodes can publish to a topic, and some nodes can subscribe to the topic. There is no response from a subscriber to a publisher. The data is only going one way. Publishers and subscribers are anonymous. A publisher only knows it is publishing to a topic, and a subscriber only knows it is subscribing to a topic, nothing more. A topic has a message type. All publishers and subscribers to the topic must use the same message type associated with the topic. As you already know, you can write a node in multiple languages using, for example, the rqt library for C++ and rqt library for Python. Well, those libraries also include the topic functionality. So you can create a publisher or subscriber in any Ros2 supported language you want, directly inside Node. Finally, a node can contain many publishers and subscribers from many different topics. To conclude, you can see that you can easily separate your code into independent nodes and make them communicate between each other using data streams over topics. Now that you understand what is a Ros2 topic, let's create a publisher with Python. So let's go to our Ros2 workspace source directory and in the Python package you've created before, and in the My Python package folder where we create all your nodes. So you already have my first node file here, and also the template Python node that I gave you on the section on nodes. So let's create a new node. We will follow the analogy from the last lecture, and we will create a robot news station file. So this node will be responsible for publishing on a robot news station. Let's make it executable. So it's important to make it executable here because we will use the symlink install flag on Qualcomm build, okay? So the file is here, and we can now edit it. So let's use the template here I have provided, okay? If you go back to my first node.py, this is exactly what we wrote in the first time to start our node, and this will be the same every time you start a new node. So we will need to change the name of the node. Let's call it robot news station node, and we need to change it here, of course. Okay, we can delete that. And we will also change the node name, which will be robot news station. And as you can see here, on purpose, I chose to use the same name for the file and the node name, which is also correct. And it's often like that when you look at other packages built by the community. Usually you have the same name for the file, for the node, and for the executable. Not every time, but sometimes it's the case. So you still have to remember that those three are different: file, node name, and executable name. But if you want, you can make them identical. Okay, we have our node here, which is just basic. You can launch it, it will not do anything. So we will add a line here to install. So put comma here, and we add a new line, robot news station. So that will be the name of the executable, and I also chose to use the same name as the file and the node. My Python package dot robot news station. So that is the name of the file right here, and we will start with the main function. So the main function will be called when we start the robot news station executable. So that's it for the setup.py. Now we can write our publisher. So to create a publisher, we will store it first in a publisher attribute in our class. We will use the method create publisher, which is from the node class. Okay, and we need to give 3 arguments. The first one is the message type. So you've seen that to define a topic, you need a name, okay, which is a common interface that all nodes can find, and a message type. So all nodes using the topic as publisher or subscriber will need to use the same message type for the communication to be successful. And so what kind of message will we send here? Because we haven't created any message, and well, we will actually use an existing message that you installed when you install Ros2. So you can just type, okay, let's type that, Ros2 interface show example, you can press tab, interfaces, MSG, and string. So let's see what we got here. So the Ros2 interface is another command line tool with Ros2, and it can help you find the interfaces. So interfaces is for the messages, and with show you can print on the screen what's inside a specific message. So we will see more about that later in this course. And the messages we will use firstly are from the example interfaces package. So this package is really great when you want to use an existing message with a basic type, and for our course it will be perfect for the beginning until we create our own custom messages. So in that package you have a MSG folder, which is for messages, so we use that for topics, and you have a string message inside that. So the show verb here with Ros2 interface will show you what's inside this message, and you can see, so we have some comments saying that it's just for examples. And the most important thing here is that string data. So the first thing is the type, which is string, which is a primitive data type for Ros2 messages, and data is simply the name of the field. So we will need to create a string message and fill the data field with a string type. Okay, so how to import this in our code? Well, simply from example interfaces.msg, okay, import string. So it is now imported in our file. And of course, this is from another package. So as we needed to use to specify dependency in the package.xml for rcl-py, we will need to do the same for example interfaces. So I will go to the package.xml of your Python package, and below that line we will add another depend example interfaces. So every time your package depends on another package, you will need to add a dependency here. Okay, so now it is set up. We can use it here. So simply put string. So we create a publisher with data type string, and then we need to give a name. Let's say robot news. Okay, so the robot news station node will publish on the robot news topic, and we need to give a queue size. So the queue size, basically, when you publish or when you subscribe, we need to give that argument. You will send some messages between nodes, and sometimes it can happen if you publish very fast, or if you publish also big messages like a complete image. It can happen that some messages are late to arrive, and in that case, the queue size will allow you. It's like a buffer, okay? It will allow the application to keep some messages before they are processed. So basically, it means here that if some messages are late, up to 10 messages will be kept, and then some messages will be lost. For this goes, and for many of your applications, this setting will not be so important. So we just put 10 as a default value every time, okay? So we have our publisher with a name and with a data type. Now we will create a function to publish on this publisher, publish news. So we call it publish news. So it's a good practice to create a function to publish on a topic. And here we will first need to create a message. So the message will simply be a string object that we got from here. So we have our message dot data, okay? We have the data field, which is directly what we saw here, okay? So message.data is equal to, let's say, help. For now, we will change it later. So we have a message, and now everything we need to do is just to self-publisher. We will take the publisher object that we got from the createPublisher method, and we will use the publish method here to publish the message. So when we call this function a message, hello will be published on the topic robot news. And now to publish it, we will create a timer. So it's quite common to create a timer with a right to publish on a topic. For example, that's what we did here. In the first node, we created a timer to we didn't publish, but we just printed some text on the screen. So we will do basically the same thing, but instead of using the logger, we will publish the message. So we create a timer, self timer, create timer. So again, this is from self, so this is from the node object. We give it a timer period, so 0.5, so we can publish at 2 Hz. And we will give it a callback, self publish news. Okay, so let's actually put a log here, self get logger, and info robot news station has been started. So it's something I usually do when you create a node at the end of the constructor. You can put a log here with info flag just to say that the node has been started, okay? So when you actually start the executable, you will be sure that this line is executed, so everything has been executed before and you are not stuck somewhere. It's quite a good practice for debugging. Okay, and before we launch the node, let's see what it does. So we will start with the main function. We initialize Ros2 publications, and then we create the node. So the constructor will be called. We call the constructor of the node with this name, so robot news station. The node will be initialized, and then inside the node we create a publisher with data type string and a name. We then create a timer, okay, which we call this function at 2 Hz. So the timer is not working yet, it's just created, and then we print something for debugging. So the constructor will exit, and we go to the rcl-py spin, so the node will start spinning until we press Ctrl+C. And when the node spins, we can still continue to call the publish news function and publish a message at 2 Hz. And when we finally decide to kill the node, then the spin will stop, and the shutdown will be called, so Ros2 communication will be shut down, and then the node and publisher and timer and everything inside the node will be destroyed automatically. So let's start this node. To start it, we need to compile it first. We need to compile the package so we can install the node. So let's here call cron build, and we will use packages select. So we only build our package, our Python package, and also we will use symlink install. So make sure you have again a file which is marked as executable, so you can use symlink install. And in another terminal, so let's first source the bash rcpy, so we can source our workspace, and then we can do Ros2 run my Python package and press start twice. We get the list of executables inside the package. So we have the Python node, which is our first node, and we have a new executable robot news station as defined in the setup by right here. So let's run it, robot news station, So we have a log, robot news station has been started, and then as you can see, the node is still alive until we press Ctrl+C. So the log is quite useful because you can know the init has been finished, so the constructor has been finished. So Ros2 node list, we can see the node directly here in this terminal, Ros2 news station. And now we have a publisher, but how can we check where is going the information and what is the information sent on the topic? You have another command line tool, we will come back to that also later in this section, which is Ros2 topic. And you have the Ros2 topic list, which will list all the topics on your graph. So you already have parameter events and Ros_out, which are always here, Ros_out for the log, and you have the robot news topic that we created in our code. So if we go back to the file, that's exactly what we have here. So you can see, if you just provide the name, you will have a slash for the global namespace will be added before the topic name. And with Ros2 topic echo, you can print what's coming from the robot news topic. And we get, oh nice, we get the data which is printed at 2 Hz. So we have that data, which is the field from the string message, and we have the hello. Let's improve a little bit. We will add a name for the robot. Let's say self-robot name equals C3PO. Okay, guess you get the reference. And we can print here, hi, this is, and let's print robot name. This is for C3PO from the robot news station. Okay, so we will print that name. So basically you can, this is a string, you can build the string as you want, and we will find it useful for the rest of the course. And as you, okay, I will kill that. As you build the node, the package with symlink installed, you can directly start it again, and you should have the new, okay, you should have the new data printed here. You have the new string. So our publisher is now complete, and as you can guess, we will need to write some kind of subscriber, because here it's nice, we can subscribe to the topic directly from the terminal, but in real applications, you will create other nodes that are subscribing to this data. Let's create a Python subscriber to listen to the radio station we've just created in the previous lecture. So we will create here a smartphone node, and inside it create a topic subscriber. As you can guess, a node which is handling a smartphone can have many features, such as reading and publishing the battery state, sending a text message to a contact, increase or decrease the speaker volume, etc, etc. So the subscriber that we create here is just one part of this node. Let's go again in the source folder of our Ros2 workspace, and we will go again in the Python package where we write all the nodes. And we will create a smartphone.py file and also make it executable. So we can edit the file from there, and as you can guess, we will use the template again. So it will be quite easy to create the base layer for the node, and let's call it smartphone node. Okay, and let's call the node simply smartphone. Okay, and what we need to do is to actually install the node. So in the setup.py, we will add smartphone, my Python package smartphone. So as you can see, maybe the first time it's quite difficult to understand everything, but now it's really easy to create a node. You just have the templates that you know you should understand, and now you add one line here, and well, that's it. So again, here I have used the same name for the executable, the file name here, and the node name. So let's add a log, self get logger info smartphone has been started. And now we can create the subscriber inside that node. So to create a subscriber, self subscriber, we create, we store the subscriber here, and we create it with self create subscription. So when you create a publisher, you have create publisher, and when you create a subscriber, you have create subscription. We need to give 4 arguments here. The first is the message type, and again we'll use from example interface message string. So we will use the exact same message that we used in the robot news station. Okay, it's very important that you use the exact same. And so it's from an external package, but you already put the dependency before, so you don't need to do that again. It's already here for that package. Okay, only for that package. So string. Then we need to give the name of the topic, and the name of the topic is this one. I will just put the exact same name, because if, for example, if you just add a new letter, it's a totally different topic, and both topics will not be synchronized. And then the third argument is the callback. So basically, when you create a subscriber and when the node is spinning, every time the subscriber gets a message, so when the publisher publishes something, a callback will be called, and you will process the message inside the callback. So let's create a function callback robot use, and this function will have a message as a parameter. Usually for callback functions for topics, I write callback followed by the name of the topic, so it's easy to find out which function does what. And well, now in that function, you will get the message that you sent here. So you will get a string message, and you can process it here. We will simply print it with self get logger info and use msg.data. Okay, data again, because from the string object, we have a data field. So we can add the callback function here, self callback robot news. And we also need to give a queue size. So in case messages arrive late, or if there is like too many messages at the same time, this will create a buffer so we can process the messages. So I will press Ctrl Shift and I, better, with the auto formatting. And well, the subscriber part is finished. So that's really not so much code to write. Okay, you have of course the base structure for the node, and then you create a subscriber with create subscription. You create a callback to handle the message you got, and you specify this callback inside the create subscription with, of course, the topic name and the topic type, which should be the same as for the publisher. So when you start the node, the Ros2 communication will be started, then the node will be created. We go here, so of course you initialize the node with the name smartphone, and then the subscriber is created, so it's just created, nothing is happening yet. We print something to say that, okay, everything in the constructor has been done, and then when you spin the node, the callback will be able to call, so the subscriber, whenever it receives a message, it will call this function from the spin functionality. And finally, when you kill the node with Ctrl+C, the spin will stop, so no callback will be processed anymore, and the Ros2 communication will be shut down with RCL by shutdown, and then everything will be destroyed, including the subscriber. Great, so we have the correct installation step here. We can go back to the Ros2 workspace, and we still need to compile again, okay, because symlink install will work for existing nodes. So if it's a new node, we will need to do that. Actually, we kill that, and let's. So if you're not sure, just source your bash RC, so you source your Ros2 workspace when you create a new file or new package. So we will start again our robot news station. So that is the publisher node. Okay, so it has been started. We can see the messages coming on the robot news topic, and we will start Ros2 run my Python package. I press that twice, and we see we have a smartphone node that we can start. And the smartphone node has been started, and we get the exact same string that this node is publishing. Okay, great. And if I kill the publisher, you can see on the subscriber, we don't receive anything, but it's still working, it's still up. If I start the publisher again, we start to receive the messages here, okay? And so both are anonymous and are not directly linked. They are only linked to the topic interface they both publish or subscribe to, but no one is aware of the other one. I can just start the node like that, it's started, and while it's working, there is no publisher, so there is no message. And then I start this one, and we start to receive messages. So congratulations, you now have two nodes which are communicating through a Ros2 topic. As you can see, once you understand how topics work, creating a topic publisher or subscriber inside the node is really not that hard. In this lecture, you will write a C++ publisher. We will do the same thing as we did for the Python publisher, but this time in C++. So you will be able to compare the two codes for the same functionalities in the two languages. So let's go in our Ros2 workspace in the source directory, and we will go now to my C++ package in the source folder of this package. Here you have my first node and also the template for the C++ node that I provided in the node section. So let's create robot news station. So we will use the same name as for the Python example, and let's edit this file. So we will not start from scratch, we will use the template here, okay, that you can find in a previous section. And as you can see, the template is just what you wrote in the first node is, well, the same thing as the template here, you just added a functionality with a timer. But once you know how to write that, well, you can use it in every node you create. So let's rename the class robot news station node. Okay, we can replace it here, and robot news station for the name of the node. Okay, so here you have a good structure for your node. And now we will create the publisher inside the constructor like we did for Python. To do that, we will need to include the message. So the string message from the example interfaces package include. So we have a HTTP header. We can use example interfaces /msg for message /string.http, and make sure you use the HTTP header. And of course, as we are using an external package, so we depend on this package, we also need to add a dependency in our package.xml. Depend, example interfaces, and depend. So that is the same thing that we did in the Python package, okay? You need to do that in every package where you use example interfaces. And also in C++, you also need to provide the dependency here in the symlinklist.txt. You can add another line, find package, example interfaces, and required. All right, so now we will be able to link this package to any node we create. So let's go back to our robot news station node. We will create the publisher here, and before we create it, we need to actually declare the publisher. So where can you find publisher? Well, simply from the RCL CPP. Publisher, you have a publisher object you can use directly from RCL CPP. So you need, as a template, you need to give the example interfaces message string object that we got from this include line. And we will add shared pointer. So if you remember, I told you that in C++ with Ros2, we will use shared pointer everywhere for almost any Ros2 functionality. And here you can see that this is just a type that you can use instead of using directly std shared pointer. So it may be a little bit more readable for you. So let's initialize our publisher, which will be initialized with this create publisher. And as you can see, I use this when using the Ros2 functionality. I don't use this for the stuff I created. I could use this for everything or for nothing. Okay, it will also work like that. But I will use it as a convention for this course only. So you know that when I write this, it's for this node. So it's clear that this functionality is from the node and it is a Ros2 functionality. So create publisher, we need to give also the type. Okay, and we need to give two arguments. The first one is the name of the topic, robot news, and the second one, the queue size. Great, so our publisher is now initialized, and we are able to publish on this robot news topic, and this is the same we used here robot news, okay? And as you can see, the name of the node robot news station is the same of the node here. So it means that if you want to launch multiple instances of this node or this node together, you will need to remap the node name at runtime. So to publish on this topic, we will actually create first a function, publish news, and we will put this function as a private one. And the first thing we need to do is to create the string message. So let's use auto msg, example interfaces, msg string. So we create a string object, an empty string object, okay? Using auto here is quite convenient because anyway, you already know the type is not that hard and it will save some space. So message.data, because this is the field. Okay, let's put an empty string for now, we'll fill that later. And publisher, as this is a shared pointer, you can use the arrow to directly get access to the functionality. So we use the method publish and we pass the message, so we publish the message. Now we will customize a little bit this string here. I will add a std string robot name that we will initialize it here, robot name to, okay, to the 2. That will be our default robot name, and here let's say hi, this is, so we need to actually use std string, so we can concatenate strings plus robot name, which is already an std string, plus from the robot news station. And now our publish news function is complete, and how we will call it is from a timer. So we will create a timer, cpp timer base, okay, and we also use shared pointer. So we create our timer, we first declare it as an attribute of the class, and we can initialize it here, timer. So again, this create wall timer, that's what you did actually in your first node here. We will do the exact same thing, but instead of just printing something, we will call the publish news function. So we wanted to call the function publish news at 2 Hz, so it is every 0.5 second. So we will use std chrono, and because we need to give integers, we will use millisecond and put 500, which is 0.5 second. And then we need to give the callback, and of course, because this is a class, we need to use std bind to bind the callback actually to this timer. So let's do that. And we will put the reference to robot news station node publish news function, and this for this class. So I pressed Ctrl Shift and I for the auto formatting in VS Code. And finally, we can add one more line just to print something. cpp info, this get logger, with our robot news station has been started. Okay, so this log is quite useful, so we know when it's printed that the node has been completely initialized. All right, it seems that this node is complete now. So again, when we enter the main function, first the Ros2 communications will be initialized, then the node is created, the publisher is created, the timer is created, and we print a message, and then the node will spin with rqt-cpp spin. And while the node is spinning, the timer will work, and then this function will be able to publish at 2 Hz. When you press Ctrl+C, this will exit, the node will stop spinning, and then you call shutdown to shut down our Ros2 communications, and then everything will be automatically destroyed because you are using shared pointers. And to run this code, we will first need to compile it, so we will go to cmaclist.txt, and we will add a new executable like we did for the first node. Add executable, let's call it robot news station. So here again, I use robot news station for the executable name, which is the same as the file name and the node name, okay? But you have to remember that those three are different. You can use the same name if you want, but those three are different stuff. So it is in the source folder here, robot news station.cpp, and we will use also element target dependencies for the robot news station. So what do we need here? We need rqt-cpp, of course, like in every Ros2 program with C++, and we will also add example interfaces. So we are saying that this executable needs both those libraries here, both those packages. This one doesn't need example interface, okay, so we don't write it here, but this one needs it, so we add it. And we already have the structure to install the executable, so let's simply add robot news station here. So for every new node you write in C++, you will add those two lines, and you will simply add the executable name here, okay, that is the executable name. And it seems that everything is ready. We can now go back to our Ros2 workspace and use Qualcomm build, and let's use again the packages select with my C++ package and see what we get here. Okay, so it has been built successfully. Now in another terminal, let's source our bash rc, and let's Ros2 run my C++ packages. Again, I press tab twice, and I get the nodes, I get the executables I can start, cpp node and robot news station. We will use that one. Robot news station has been started, and as you can see, the program is still running because it is spinning. If I kill it, it stops and I can start it again. And now with Ros2 node list, you can see the node here, Ros2 node info robot news station. You can see that we have a publisher here, robot news. It's appearing here because we are publishing from this node. So robot news is the name of the topic, and the interface is right here, okay? So Ros2 node info is quite convenient to find the topic. So we will do Ros2 topic list, and the topic is right here, robot news. Let's see Ros2 topic echo robot news. Let's see what we get here, and you can see hi, this is rqt2 from the robot news station, okay? So it's working. And now that you have seen how to write a publisher, of course we will go to write the subscriber. But before you do that, In fact, you already have a subscriber for this node, and you have a Python subscriber. And you will already see here that this is really the magic of Ros2. I told you that Ros2 is language agnostic, and you will really understand it here. It means that you can create a node in C++, for example, you can create another node in Python, and both nodes can communicate between each other because it doesn't rely on the language itself for the communication. It relies on the lower level, which is the same for all nodes. So if I start Ros2 run my Python package, if I start the subscriber, so it is in the smartphone node. So the smartphone here will subscribe to the robot news topic, and what are we doing here? We are publishing on the robot news topic. Okay, so I'm just starting the Python node, and as you can see, we are getting the messages from the C++ node. Okay, you can see that if I kill this C++ node, we don't get any message here anymore. So that is a really, really powerful functionality of Ros2. And now let's see how to write the subscriber in C++. In this lecture, I will show you how to create a C++ subscriber. So we will use again the same example as we did for Python, and we will create a smartphone subscriber for the robot news station publisher we've created just before. So again, we will go into our C++ package in the source folder where we already have our node, and we will create a new smartphone file. Okay, we can now edit this file here. So we will again copy and paste this and write smartphone node here. We copy and paste that and write smartphone. Okay, our structure is now ready. We will, of course, include the example interface message string.hpp. Okay, and we don't need to add it here again because it's already here for our package in the synclist and in the package.xml, so we can directly use it. So let's create our subscriber. We will actually need two things, a subscriber object and a callback, so we can manage and handle the message that we got. So let's call this callback robot news. What we will get here is a const of a example interfaces msg string and shared pointer. Okay, so we get a shared pointer of the message. And again, you have the easy way to write a shared pointer with Ros2. So for every message you will get in C++, you will use, for every callback, for every subscriber, you will use const, then the name of the message, and finally you add shared pointer. Okay, so it's always the same. And let's simply print this message with rqt-cpp info. We get the logger for the node, and we will print a string. As this is a shared pointer, we use the arrow and data. Actually, this is a std string, so we'll use the cstr function to make it usable with this rqt-cpp info function. Right, so our callback is now ready, and what we need to do now is to create a subscriber to actually call this callback when it receives a new message. So let's first declare our subscriber rqt-cpp subscription. So we create a subscription. We need to give the type example interface msg string, and this is a shared pointer again. Subscribe, so we put subscriber in the code, right? Okay, and we can now initialize the subscriber inside the node constructor. Subscriber, we will use this again, create subscription, and we need to give the example interfaces message string, so we need to give the interface. And now we need to give three arguments. The first one is the topic name, robot news. The second one will be, pay attention to that, the second one will be the queue size, okay? And the third one will be the callback. So for the callback, we will need to add this, and of course, we will use stdbind. So well, for any callback you will create with C++, in the node class we use stdbind. We put the reference to smartphone node callback robot news, this, and we need to add another argument here in the stdbind function because we have here a parameter for the function. When we used here in my first node, when we used our just in the robot news station publisher, we created a timer for this function, but this function has no parameter, so we just had two parameters for stdbind. But now, because there is a parameter here for this function, we need to add std placeholders and one. Okay, so this is required for every parameter you have in a callback function. If you have two parameters, you will write another argument here, std placeholders 2. So let's make it more readable like that. And let's add a log, rqt-cpp info with this get logger. And this is smartphone. Smartphone has been started, so we know it has been initialized. And our subscriber is now ready to be used. So to recap quickly, we initialize Ros2 communication, we created the node, the subscriber will be created with the callback function here. It is not working yet, it's just initialized, and then we spin the node so it will be able to receive and process any callback, and when it receives a message, this callback will be called for the robot news topic. And when we press Ctrl+C, the spin stops, so we don't receive any new message, and we can shut down the Ros2 communications. So to use it, we will add it here, add executable smartphone, which will be the executable name, okay, src smartphone.cpp. We add element target dependencies for the smartphone executable, and we need rqt-cpp and also example interfaces. So that we create the executable, and now we install it. Smartphone. Okay. You can go back to your Ros2 workspace and again build the package. Okay, so let's try our new subscriber. I will source the bash IRC to source the environment, and Ros2 run my cpp package with smartphone node, which should be here. Yes, so the smartphone has been created. We can see it here, Ros2 node list. Okay, and this smartphone has subscribed to the robot news topic, but actually no one is publishing on this topic. So let's publish with the C++ robot news station, and we are getting some messages here. Great. Now I kill the publisher and we don't receive anything from the subscriber. Let's try actually Ros2 run my Python package robot news station. So now I will launch the Python publisher that we created before. Okay, and we get some messages here. Okay, as you can see, I chose a different name for the Python and C++ version, and you can see it here. Okay, this is coming from the C++ node, and this is coming from the Python node. But actually, the subscriber can't make the difference. Okay, it's just a topic, so anything that is sent to the topic with the correct data type will be processed. Great, so you now have a complete C++ publisher and subscriber. In this lecture, you will see how to debug your topics with command line tools. So we will again use the Ros2 command line interface. You've already seen how to use that to work with nodes, with Ros2 node, with also Ros2 pkg to create packages, and Ros2 run to start your node. And now you can have the Ros2 topic to handle topics. And if you press tab twice, you will see all the other functionalities you get for topic. In fact, in this section, you already saw Ros topic list and Ros topic echo. So let's start Ros2 run let's start any node, my Python package robot station. So we start a publisher for a topic. Let's see Ros2 topic list. We now have the robot news topic here. If I kill the node, you don't have the topic anymore. Okay, and if I start the node again, you have the robot news topic. Now, if you want to get more information about that topic, you can do Ros2 topic info and put the name of the topic. And this is very useful. You can see the type and the number of publishers and subscribers. So here we have 1 publisher and 0 subscriber, okay? So if you want to create a new publisher or subscriber, you know that you need to send data to the robot news name and with this type. Now we can Ros2 topic echo, we can echo the message. So we can create a subscriber inside the terminal. Echo robot news, so we put the name of the topic, and we have the data which is printed here. If I do Ros2 topic info again, you can see we have 1 subscriber here. If I kill that, we still have 1 publisher, but no subscriber. And there is a command line that you can use to complete this is Ros2 interface that you saw already before. You can do Ros2 interface show with the type. Okay, and this will print the actual message definition, so you know what you need to send for this topic. So with Ros2 topic, you can also use the HZ functionality, which means hertz, and you can actually get the publishing frequency for a topic. So let's experiment with the robot news topic, and if you wait a little bit, so it will listen to the topic, and it will print the average rate, which is here 2 hertz. So it's great because we have 2 hertz here, and we know that we are publishing at 2 hertz from the publisher, so everything is functioning correctly. And this command can be great for debugging. For example, if you have a very high publish rate and you see that the messages are not following quickly enough, then you can see that maybe the rate has dropped, and you can monitor that with HZ. You can also use Ros2 topic BW for bandwidth, robot news, and to see, okay, subscribe. So you can see the bandwidth used for the node. So here it's just some text at a very low frequency. So we have 200, like 140 bytes per second. Okay, this is an average you get. And finally, you can also publish directly from the terminal. So usually you will often use the Ros2 topic echo command, the pub command, Ros2 topic pub. You will not usually use it a lot, but it's still good to know it. So let's say you want to publish at 10 hertz, you can use -r with 10, and let's publish on the robot news topic. You can use the auto completion, okay, with tab. Example interface is string, and then you will need to give the message. So you can use like that 2 curly brackets, and we need to send data, which is let's say hello from terminal. Actually, let's use that. Okay, and it's publishing. So if we are subscribing here, okay, you can see that we get messages from the publisher here, and we also get the messages from the publisher here. So we have 2 publishers and 1 subscriber. So to recap, Ros2 topic, let's see what we get here with the tab. The most important ones, you have echo, so you can see what is actually going through your topic, the list to list all your topic, info to get info about the topic, and then you can use also BW and HZ to debug the topic. And if we look at the node, let's say Ros2 node list, we have the node here that is running in this terminal. If we do Ros2 node info with this node, we will get all the publishers and everything that are created for this node, and you can see we have the publisher robot news here. So from the node information, we can see which topics this node is actually publishing to or subscribing to, and from that you can then use the Ros2 topic info to get more information about that topic. In the previous section with nodes and Ros2 run, you have seen that you can rename a node at runtime. So as a reminder, you can do, for example, Ros2 run my Python package with the robot new station, and you can rename the node. You first put Ros args and then with dash r and node like that. You can rename, let's say, my station. So this node is now running my station. Okay, if you do Ros2 node list, you get my station. And if you do Ros2 topic list, you can see that this node is publishing on the robot news topic. So now how to rename that topic? Well, you simply keep the same thing. You add Ros args and then you add another dash r argument with simply the name of the topic, robot news, like that. Let's say we want it just to be my news. So if you do that, then when Ros2 will start your node, it will search for something that has the same name as robot news, and it will rename with my news. Okay, so I start the node, and if I do Ros2 topic list, then we have my news topic. So the robot news topic has been renamed to my news topic. It has been remapped. And as you can see in the code, so any code here in C++ or Python is the same. We have specified the name here, and even though we have specified the name in the file directly hard-coded here, we can still modify it at runtime with this argument. So now let's see what happens if we launch a subscriber, for example. Ros2 run my Python package. Let's start the smartphone subscriber, and let's see if we get some messages. And oh, we don't get any messages, but we have launched the publisher. Yes, but the publisher is now publishing to a different topic. If you do Ros2 topic list here, you have my news, which is what this node is publishing to, and now you have robot news because we now have a subscriber for this topic. But those two are different topics. So if you want to get information from that topic, you will also need to rename it here, Ros args with dash r and robot news, my news, and now you will get messages. Okay. So remapping topics will be quite useful in your applications. For example, when you have an existing publisher and you can change the topic name, then you can change the topic name for the subscriber if it's not the same in the code. And in this course, we will also work more with remapping, and you will see some of the benefits you get with that. Let's see how to monitor topics with rqt-graph. So I will first launch rqt-graph here in this terminal, rqt-graph, okay, which is now empty because we don't have anything in the graph. And I will start a first node here. So Ros2 run my, let's launch my C++ robot news station. We have a publisher, and let's start Ros2 run my Python package smartphone node. So we have a subscriber for the same topic and it's working. We can now go to the rqt-graph here, refresh, and you see what's happening. We have robot news station node, which is publishing on the robot news topic, and the smartphone node is subscribing to the robot news topic. You can change the view here. Okay, this is maybe better. So you have the topic square is a topic, and this is a node. So this is publishing on that topic, and this is subscribing to that topic. And now let's experiment a little bit more to see what we can do with this graph. So we will start another publisher, Ros2 run my. So let's use the Python one. It doesn't really matter. Robot news station. Of course, we need to change the name, because if we don't change the name, it will also have the robot news station name, and it is not valid. So we will change the node name here. We'll not change the topic name. Node. Let's say my station. Okay, we have my station, and as you can see, the subscriber is now getting messages from both publishers. If I refresh here, you can see we have now two publishers on this topic. I can add yet another publisher. We'll just rename my station 2. Okay, and we refresh and we have 3 publishers on that topic. Okay, it's quite simple. And now we can add another subscriber here. Ros2 run my Python package. Let's run another smartphone and rename it. So we need to do Ros args -r node and smartphone 2. Okay, and we get, of course, a lot of data because there are 3 publishers. And right, so both the smartphone and smartphone 2 nodes will get the messages from robot news. So those 3 will publish on that topic, and those 2 will process all the messages from that topic. And this node, as you can see, doesn't know the existence of all the other nodes. It's completely anonymous. And now let's add some remapping for the topic. So I will keep that, and I will add here, I will add 2 other nodes. So I will start Ros2 run my Python package. I will start another robot news station. So I will remap the node first, like that. Let's say other station, and I will also remap the topic. So robot news, and let's use my news. Okay, and what we get here now, you have the other station node, which is publishing but is not publishing on the robot news. So you don't see an arrow here, okay? And now we will create a subscriber, Ros2 run my Python package smartphone. We will actually also change the node name. We will name it other smartphone, just for convenience, and we will rename the topic robot news, and this has to be the same topic name if you want to listen to that topic. And we get messages from this publisher. So as you can see here, what we did, we have a different topic. So this basically from the node is the same node and the same topic and the same subscriber, but at runtime we were able to make a complete different configuration. So you can see how remapping nodes and topics is very powerful. In this case, for example, we want to have communication through the topic, but we don't want to mix everything. For example, that station should not publish for those nodes. We don't want those smartphones to get from that station. So we will remap the topic, and of course, the other smartphone will need to remap the topic to listen to this one instead of this one. In this lecture, we will experiment a little bit on topics using the Turtlesim package that you already saw in the previous section. So first, we will start Ros2 run Turtlesim. We will start the Turtlesim node. Okay, we have the turtle, so I will resize this here. Close that. And so we have our turtle. We will start Ros2 run Turtlesim turtle key. So we can actually move the turtle. And if we Ros2 node list, we can see we have two nodes, Ros2 node info on Turtlesim. So Turtlesim is the node with the window. We have, okay, I will, but in full screen we have many things, but you can see here we have subscribers, Turtle1, common velocity, which is getting a twist message from the geometry messages package. Okay, if I do Ros2 node info and turtle, you can see in the publisher we have the exact same topic. So this node, we saw before that this node is sending data to the Turtlesim node, and you can see now that it is through this topic as a publisher here and as a subscriber here. So if you want to see what's inside that interface, you can do Ros2 interface show geometry messages and with twist. And we have a comment, and we have a linear field and angular field. And actually this is another type. This is another message. So you'll see later that you can include messages in messages. So Ros2 interface show geometry messages, and we can use the vector3. The vector3 contains three fields, x, y, and z, which are float64. This is another primitive data type. So if you want to add a new publisher or subscriber to the topic Turtle1 common velocity, you will need to send first vector3, so x, y, and z for linear velocity, and then vector3 for angular velocity. And let's put this back here. If I do Ros2 topic list, I can get the list of topics, and we will check the Ros2 topic echo Turtle1 common vel for common velocity. So, of course, there is no command here because we are not doing anything. If I start to press the key here, you have new command sent to the Turtlesim, because this node will monitor the keyboard and send a message on the topic when you press a key. And you can also see what's happening with rqt-graph. So let's start rqt-graph here. You can press refresh if it's not on screen, and make sure you have checked nodes and topics here. So yes, we have our Turtlesim node, turtle node. You can see the topic here, topic name. That node is publishing to the topic, and that node is subscribing to the topic. So you can experiment more on your own with Turtlesim. For example, you can remap node names. You can also remap the topic, and you can see what's happening, and maybe try different nodes with different remapping to see the different options and configurations you can get. This is the solution to the previous activity, in which you have to create some kind of a data pipeline between multiple nodes using topics, so publishers and subscriber. I will only provide a video solution for Python, but you can also download the complete solution for C++ at the end of this section. The C++ solution will be exactly the same, just using the C++ syntax and SCLCPP instead of RCLPy. So let's first create our number publisher node. Okay, it will be easier to start this way, so we can at least check and know that the number publisher is working correctly before we try to implement the counter. So we go again in our Ros2 workspace, so start directory, and in the Python package, in the folder where we write our node, let's create number publisher.py, and let's make it executable for symlink install flag for Qualcomm. Great, so now we can edit this file. Number publisher, here it is, and now we will always do that. Number publisher node. So we'll rename file here and number publisher. So again, the name of the file here, I chose to use the same for the name of the node. So the first thing we can do is to actually add a new line here, so we can install the executable. So number publisher, which will be the name of the executable, my Python package dot number publisher, and the main function. Okay, don't forget to add a comma between each line. Okay, otherwise you will get an error. You may not get an error, but when you start with Ros2 run, you will have something quite weird. So we go back to number publisher, and as I told you, we need to use the example interface message int64. So let's check what we have in this message interface. Ros2 interface show example interface is MSG, and then we have int64. Okay, and we have another message definition with the four lines, the four comment lines, which will be in all example interfaces messages. And we have a field named data, like the string message. It's the same field, but here instead it's an int64 primitive data type. So it just means it's an integer number. Okay, so we will say from example interfaces .msg import int64. And the good news is that we don't need to do anything else for the example interfaces because it's already here in our package XML. We already did the job when we used the example interfaces here because it's the same package, so we don't need to import it multiple times in the package.xml. So inside our node, we will first, let's say that we create a number attribute. Let's say we want to send 2, and we can create our publisher. So again, let's say number publisher. So it's important to give meaningful names to your variables. Here it's a publisher for a number, so we can call it number publisher. Self create publisher. We need to give first the type int64. We need to give the name, which is here number. So the number publisher node will publish on the number topic, and a queue size 10. Now we will create a function publish number. So also give a meaningful name to that. We don't give the number as a parameter here because we use the number from the class. Okay, so let's create a message which is an int64, and that message has a data field, okay, which we got from here. So we fill that field with the number, self number, and then we can publish with the publish method of the number publisher object, and we publish the message, of course. Okay, we have a function to publish, so let's create a timer, number timer. Okay, self create timer. So I didn't give you a publish frequency here, but you can do whatever you want. I will say that we publish at 1 hertz, okay, for example. So 1 hertz means the period will be 1 second also. And we can specify the publish number as a callback for this timer. And let's add a log, self get logger info number publisher has been started. Okay, so the node is now finished. Well, this is a classic publisher. We create a publisher and we create a timer to publish at a given rate here. So if you don't understand here and if it's still hard for you, I recommend you check again the lectures on how to create a Python publisher. I give much more details than here. And now everything is ready. We can see here the line for the number publisher executable is written. We can go back to our Ros2 workspace and build it. Call build. Okay, I will just use call build like that. So you can see we build the C++ and the Python package, okay, which can take more time. So next time we will use call build with packages set. And I can here run Ros2 run my Python package, and we have a new executable which is named publisher. Number publisher has been started. If we do Ros2 node list, we have the node Ros2 topic list. We have a topic number and Ros2 topic echo number. We have the data which is coming every second. So now that we are sure our publisher is working correctly, it's time to create the subscriber, which is the number counter node. So let's create the number counter node, which will do two things. First, it will subscribe to the number topic. Now that it exists, we can subscribe to it. And then it will publish to a new topic, number count, to actually publish the number count that we will compute inside the node. So let's go inside our Python package again. And here we will create a new file named number counter.py. We make this file executable. Okay, and then we will edit. So number counter, it's here. As always, we can start it quickly like that. Number counter node. Okay, we can replace it here also. And number counter. Third thing, we will create a subscriber for the number topic. So let's create a subscriber. So number subscriber. We will create it with create subscription. The first thing, the first argument is the message type, so we need to include it here from example interface. Message import int64. Make sure it's the exact same as in the number publisher. Okay, it's very important. So we already added the dependency for this package in our Python package. We don't need to do that again. We can simply put the message here and then specify the topic name, which is number. Then we will be able to put the callback function. So let's create a callback function. Callback number. It will receive a message. Okay, let's make it empty for now. We can specify it here, callback number, and let's put a queue size 10. Okay, a little bit of magic to make it more readable. So what we want to do in this callback is not only print the message, okay, like we did before, we want to actually do something. So we will add the number that we get to a counter. So we will create a counter here. counter and initialize it to 0. When we receive the message, we will add it to the counter plus message.data. So every time the subscriber gets a message, the callback number will be called, and we will get the actual integer from message data, so we can add it to the counter. Let's just print it for now. Before we write the publisher, let's print it. Self get logger info and simply put self counter. And also we can add a log here, self get logger info number counter has been started. Okay, we need to add it here so we can install the executable. So let's add a new line, number counter my Python package number counter name. Okay, so that's yet another line. So you can see we start to fill this array with multiple nodes. And let's go to our Ros2 workspace and call build packages select with my Python package and the symlink install, because we will modify the file later, so it will be more convenient. Okay, let's source /rc. And now we can run the new node Ros2 run my Python package. Let's launch the number counter node, and it has been started, so nothing is printed because we didn't publish anything on the topic. So Ros2 run my Python package number publisher. And when we publish something, you can see here we receive the data, and every time the counter, the data is added to the counter. Okay, I press Ctrl+C, and so you can see we already have our counter, which is internal to the node. And now all we need to do is to create a publisher to publish that counter. So let's do that. We will of course use the same node, and here we will create the publisher right here, self publisher. So number count publisher, because we will publish a counter, which is self create publisher. We need to give a type. So which type will we use? Well, we will use the same type, because when you add multiple integers, where you still have an integer, so let's use the same type. And then we need to give a name to the topic. We will give the name number count. So we have a different name as the number topic, and of course a queue size. So as you can see here, in one node you can have a subscriber, and you can also have a publisher. Okay, you can have any number of subscribers and any number of publishers you want for any topic. So we have this publisher, and what we usually did before when we had a publisher is we this is the number publisher node. Every time we created a timer with a function to send a message, but here we want to do something different. We want to publish the counter when we get a new message and when the counter is updated. So instead of creating a different timer with another callback, we will simply send the message to the number count when we actually get a new message. So in the callback of the number topic, we will increase the counter, and we will publish to the number count topic. So I will remove that line here, and we will simply create a new message, which is an int64 message. So actually, let's call it new because we already have a message here. And in this new message data, we will put the counter value. And now we can use the publisher we created before, number count publisher, publish new message. Okay, and that's it. You see, it's not that complicated. You just create a new publisher and you can use it in your callback. And here, as you use the publisher inside the callback of the subscriber, it's better to initialize the publisher before the subscriber, just in case you may have an error when you launch the node. So now we can run the node. As we use the symlink install, we can directly, without compiling again, we can start the subscriber again, the number count again, which is in fact here. So we start the number publisher, and we start the number counter. Okay, number counter has been started. Now we don't have any log, but if I do Ros2 topic list, we can see we have a number count topic, Ros2 topic echo number count. We should have the counter, which is increased. So on this topic, you have the data. You can see 60, 62, 64, etc. Well, this activity is now finished, and congratulations if you managed to do all the steps or even a few steps of this activity. And actually, okay, it's still running. Let's do rqt-graph to see what we have here. And you can see we have the number publisher node publishing on the number topic, which is then going to the number counter, which is subscribing. And we don't see here the number count topic because no actual node that we created is subscribing to it. So if you want to see it, you can remove those two options here. And okay, you have many things here with the rqt node and the daemon stuff and rolls out, but you can see the number count here. So the important things are just here. The number counter node is publishing on the number count topic.